I'm putting it.
And run.
Okay. Good afternoon, everyone. Welcome back, and thank you for joining us for the third innovation webinar hosted by Smart2B. My name is Simona Mollo, and I'm in charge of the communication and dissemination activities for this project. For those who are joining us for the first time, Smart2B Innovation Webinars are a series of online events that we're hosting since July 2022, and that will continue until November 2023. These webinars have multiple goals. First, giving visibility to the European Commission initiative for energy transition. Secondly, deepen the technological challenges related to the concept of smart buildings. And finally, spreading information about the results and the achievement of our project. Today, we will focus on the Smart2B platform. We will learn how a community-enabled smart readiness platform can support the creation of an open competitive market for energy management services. We'll also learn more about the integration of the platform of IoT devices for upgrading any kind of buildings. And the webinar will also be an opportunity to discover more about common data ontology in the energy domain and the relevant interoperability challenges. Before we start, let me give you a couple of additional forwards. The Q&A session will take place at the end of the last speech. Feel free to share any question during the webinar through the dedicated chat below. I will collect all the questions and the speaker will answer at the end of the session. Please also note that the session will be recorded. You will find the video on our channel in the next few days. Let me introduce to our first speaker, Jesus Sanchez Gomez. Jesus is a senior researcher at Audience, a company based in Spain devoted to the design, development, and implementation of intelligent solutions for smart cities, industrial processes, and machinery. He will introduce us to the Smart2B platform and its impact on the market, and also its implementation. Please, Jesus, go ahead.
Thank you very much, Simona, for the presentation. So we'll share my screen now. I hope that you can see my screen. Okay.
Yeah, we can see that.
So I'm going to introduce you how we are implementing Smart2B, a community-enabled smart readiness platform. In this slide, you can see the overall architecture of the whole concept of Smart2B, and I'm going to focus on the mid section, which is actually the platform. So the goal of this platform is to enable developers and service providers to integrate and commercialize their solutions through standardized protocols. The way that we have approached this is through several different objectives that we have conceived in Smart2B, and I will briefly go over them to kind of give you a sense on how we can achieve that goal. So first, I will talk about the harmonization of heterogeneous data. The idea is that devices are employed to control equipment in remote areas. These IoT devices are typically working without human supervision, and they don't have keypads or displays that enable the users to interact with them. So all of the communication has to go through some kind of software or platform component. The problem that we have is that, well, let's say that the IoT catch every company by a storm. They rush their own solutions to the market. They try to make everything work as soon as possible and put their products out of the window as fast as they could. So they were not concerned about standards or different protocols or formats that are used by their competition. So what we achieve is a kind of, let's say, heterogeneous space where many different vendor-specific formats are coexisting today. So what we are trying to do here is to actually mitigate that problem through the use of standardization and data formats that are compatible with several different companies or vendors. So the Smart2B component that is receiving the information from the devices themselves, it's called a broker. A broker follows a publish and subscription model, which means that the devices are going to employ a standardized format to communicate the information about their measurements against the platform. And this information is going to be, let's say, treated or processed so that the services can work out what to do with this kind of knowledge. Not only we receive information from the devices themselves, we also receive information from third-party data sources. For example, we have integrated in the project the information about the day-ahead energy cost. So we can tell at which point the energy is going to be cheaper and try to capitalize on that opportunity. At the same time, we also integrated through several open APIs weather forecast information. The next objective of the platform is to design and develop building data models and achieve automatic semantic and data filtering. So data filtering and semantic annotations are processes that basically enhance the data. The data filtering is extracting specific data that makes easier to process larger data sets. And the semantic annotation is basically adding descriptive information that is going to be used by the services. All of this is a process that basically helps make sense of large data sets. The way that this works, very briefly, is that we receive the raw data measurements from the sensors. This information is published at a broker, which is, as I said, is a published subscription platform. The data filtering and semantic annotation process that raw information into what we call process data. And all of that is stored back in a long-term storage solution. So this is going to facilitate services to actually get more valuable information to do their work. To standardize all of the different vendors that we have, all of the devices have different formats, they have different protocols. So what we reach is what's called a data model. The data model is basically an implicit way of making sense of the data that we have gathered. So we are using what are called smart data models, which is a European standardization effort, which has many different companies in the consortium. And these data models are basically the format that the information is going to be presented. So this facilitates the work of the services by not having to specifically know how each of the vendors or each of the devices format the information. So there is one single way of understanding the data. There's one single way of providing the data. The next objective is about achieving a knowledge extraction system and also apply unified orchestration for the actuation commands. What this means is that the information that we gather from the devices can be represented in what is called a knowledge graph. A knowledge graph is basically another different structure that is storing knowledge to make it easier to understand by machines. So all of the data that we gather is actually, let's say, reprocessed or restructured into one of these knowledge graphs. Not only we get information from the services, but from the devices, but also we get feedback provided by the occupants. Another innovation is the unified orchestration of the actuation. So the point is that sometimes the services can send requests of actuation that are conflicting, or they are against the overall requirements or constraints of one of the deployments. So what we have here is a component that is in charge of orchestrating all of the high-level actuation requests. So this has two main purposes. Basically hides the complexity of the devices. This doesn't require the services to know exactly how they can actuate on the devices, and also coordinates potential conflicting commands. So if one service is trying to turn everything on and another service is trying to turn everything off, which is the one that is supposed to be taking place. So that is one of the let's say, purposes of this component. Next component is the design of what we call the platform APIs. So as you see, we have talked about different features and different components. But what we want with this concept is to actually make things easier and to accelerate and enhance the development of the services and the integration of applications. So to achieve this, we have conceived one single entry point to manage in a, let's say, cohesive way all of the features that are offered by the platform. So what we call this is the platform API, which is the component in charge of connecting everything from the northbound to all of the components that are inside the cloud platform. Finally, about security, we have implemented what we call a cross security and privacy cross layer. So what this means is that in the whole concept of the architecture, and you can see in the picture, we have a cross layer that is in charge of making sure that the data is secure among the different communications, little bit the devices, the platform itself, and also the services and the applications. So what we have here is a set of components that are implementing a set of features that allows an scalable and a feature-rich security enhancements for the platform. And scalable is a pretty key concept here because we expect to have several hundreds or even thousands of devices connected to each one of these platforms. So we have leveraged on distributed capability tokens, and also on technologies like attribute-based encryption that are pretty much aligned with the IoT realm, with the low constraint devices, and also together with the massive deployments. Finally, as a final remark, regarding the deployment, the concept of this platform is that it is supposed to be flexible and be modular. There is only one single platform per deployment. So in case that you have an administrative domain with several buildings, you can, let's say, deploy one single instance of the platform, and the platform is scalable and flexible. All of the components are developed over free software, which means that they are focused on open standardization, and you don't have to pay for expensive licenses, and you're not constraining yourself to vendor lock-in issues. Well, basically, this future-proofs the solution no matter what happens, even if the companies go under, the Smart2B platform will prevail. And also to improve the let's say, deployment to make things easier, we have also focused on capitalize on virtualization technologies like Docker. And yeah, a modular design grants the possibility to enhance with new components that I have not described previously that are going to, let's say, add more functionality to the platform. So that's all from me. Thank you very much for your attention.
And thank you very much, Jesus, for your contribution. Again, if you have any question for our first speaker, feel free to write them in the chat below, and we will be answering them at the end of the session. Now it's time for Anastasis Tsumpas. Anastasis is Head of Unit of Electrical Power and Energy Systems at UBTech Energy. In the framework of Data Cellar project, UBTech aims to create an energy data space that will support the creation, development, and management of local energy communities in the EU. Anastasis will introduce us to the methodology for a common data ontology in the energy domain and relevant interoperability challenges. Please, Anastasis.
Thank you, Simona. I thank you for the invitation. I'm very glad to be here. Let me share my screen. I think you can see my screen now.
Yeah.
Yes.
Okay, so I would like to say a few words first about Data Cellar in general, and then to focus on the common ontology development activities that we are leading in this project. So Data Cellar is a data hub for the creation of energy communities at local level and to
Sorry, I think we have a little bit of a technical problem. Anastasis, can you hear us? Okay. So maybe we can move to Stefano while we wait for Anastasis to come back, or maybe let's wait 30 seconds and then maybe we can go ahead and then come back to the second speaker. Okay, so I think that we can move for now to Stefano Bianchi, that who is Research and Innovation Manager in Algovat. Stefano's presentation will focus on the challenges in bridging the gap between research activities and solution delivery for partners and customers. And he will do so through a case history. Please, Stefano.
We have
okay.
Anastasis back. I don't know
Anastasis,
if you want to...
Yes,
do you want to resume your
apologies.
presentations?
Sorry, there was a power outage and now I came back. Sorry for that.
Okay, so we can move back to the original agenda if you're okay with sharing your screen again.
Yes, thank you very
sorry,
much.
Stefano.
Sorry for that. So I was about to say about the overview of the project of Data Cellar. We have in total 9 validation cases and 2 data providers. The main objectives is the development, validation, and demonstration of a dynamic data hub to deliver data-driven energy services to support the energy transition. We focus on DLT-based open marketplace and novel business models, and implement privacy and cybersecurity by design. You can see in this map the companies and the countries that are participating. So the use cases that we are focused on is regarding a scientific community data analytics developers. So we develop the relevant marketplace with data sets and artificial intelligence and machine learning libraries. Energy communities about the optimization of the sizing of renewables, the resource management, environmental and economic assessment, as well as energy consumers and prosumers for flexibility estimation and building energy performance. The main, let's say, modules that the main services that will be available from data space will also have a decision support system, digital twin capabilities, the marketplace, as well as a dashboard to make available all these resources. This is the consortium. The project is led by Irina. We have many partners from the industry and the academia. So moving on, we would like now to focus on the methodology that we have used for developing a common data ontology. And here you can see the high-level process. So we have first the stage for the ontology requirements, the data classification, then the semantic, let's say, phase about the ontology implementation. The ontology publication will follow, as well as the ontology maintenance. And of course, this ontology development will feed, let's say, the activities for the data model definition. Currently, we are at the stage of the ontology implementation. Here you can see the energy domain classes that we are currently focused on. We also take into consideration the domain agnostic aspects in order to handle interoperability requirements. Here you see that we have, let's say, the in the taxonomy, smart devices, energy generation technologies and sources, energy transmission and distribution systems, energy market structures and pricing, the consumption and usage patterns, storage systems and technologies, the regulation policies and standards, as well as energy efficiency and conservation practices and technologies. We have decided to follow the linked open terms, so-called LOT methodology for the ontology development. Here we have three main dimensions that we focus, the actors, the activity, and the outputs. And for each, for the first two main, let's say, activities, the ontology requirement specification, as well as the ontology implementation, I will show you the next two slides in a little bit more detail. So here we have the ontology requirement specification process, and we start from the use cases specification and the description of the data exchange. Then we extract the functional ontology requirements, and we have, let's say, also the concept of the ORSD formalization, which are tables that questions are being, let's say, listed and trying to be answered more as much detail as possible from the actors. Regarding the implementation, we focus here in this diagram. So we have, let's say, the first step, that is the ontology conceptualization, and we usually have various tools that we do this, and we have selected Protégé. It's a very nice tool, and we have proceeded with these steps. And we have also the ontology encoding and ontology evaluation. And it's an important step to define which ontologies from other projects or standards are going to be reused, either in full, either partially. And for that reason, I have the final slide that I can show you here. The energy management system ontologies that we have already, let's say, reviewed and partially or fully are reused. So for smart devices and conceptualization, SARF and BEAMER are fully reused, and we have also identified interesting, let's say, ontologies for Patera, the Open Entrance, of course, IDSA, OpenDI, and Firewire. This was the introduction to this topic that I would like to share with you, and I will be glad to answer any questions from the audience. Thank you.
Thank you very much, Anastasis. And of course, we will be answer every question in our Q&A session. Now I'll pass again the word to Stefano Bianchi for real this time. As I was saying, His presentation will focus on the challenges in bridging the gap between research activity and solution delivery, and he will do so through a case history. Please, Stefano, go ahead.
Yeah, thank you, Simona. Thank you all for the invitation. So let me first of all share the screen, and that's it. I assume you see my slides. So
Yes.
it is good I come at the end, because we have seen a couple of the Smart2B introduction, then results from a research project, and the invitation here is bridging the view from the research down to implementation in a real case study in that sense. So just a few words about why we are here. As an Argovat, we are a green tech solution provider and a system integrator covering most of the energy chain from the generation down to efficient use through different steps: transmission, distribution, market, energy efficiency, and energy monitoring. So the results that I'm showcasing today is the results of our expertise in several fields. I selected one of these as for the significance and the relevance of the challenges that we faced according to what the Smart2B project is doing, and also I think compliant in compliance with what Anastasis was showcasing before in terms of ontological approach in order to homogenize the use and the interface and the interoperability with among the systems and with the field devices. So for doing this, of course, as we said, we need a bridge between the research and the development of the solution. This is what we do in Algavat, and this is what the Research and Innovation Department is doing, also in collaboration with some of you, with the deans in several research projects that we are doing nowadays, and that could be also good to present in future webinars if you want. Bridging the gap means taking the results from the research project, industrializing them, and then bringing them in the product portfolio of the companies participating, which is not a straightforward process. It can be hard for several reasons. I have highlighted at the end of my presentation a few lessons learned, the key issues and key takeaways that you can consider further on in the question and answer session in order to build upon this expertise. So what is the case history or case study we're presenting today? It's about a smart building project for a primary bank group in Italy that we have been doing for several years now, and that encompassed the integration of several different assets. What we have done there, we have proposed to our customer our building energy management system as AnyBAMS. This is a solution that includes several different complementary functionalities, from a facility management down to the proper control, remote control, monitoring control of HVAC system, electrical and mechanical system, energy management, lighting, even safety, workspace management, asset management, and last but not least, this is something interesting and really worth of consideration, the integration with user and occupants in terms of, for example, perceived comfort in terms of occupation. The solution that we propose is something we take out of our portfolio, a portfolio that has been built also thanks to the participation to the research initiative, similar to those Smart2B or Data Cellar, those that has been presented before. This is a typical, we say, architecture you see on the southbound, as you say, the typical integration with the field through some fully industrialized hardware, the RTUGO and P48 system that we developed for the load curtailment in transmission networks, and that we have adopted also to interact with the field here. Then we have the core modules that provides the integration of the system from different devices, and then we have the vertical application on the right part of the slide, where we have the building management, resource management, energy efficiency, energy analysis, the things that our customer was interested in when trying to have a more close control, visibility of the assets they are managing in their headquarters and facility all around Italy. So to implement a centralized supervision and control system, we had to tackle a couple of complementary steps with different sub-steps, so to say. So the interface with heterogeneous field devices, of course, when you go and have to integrate several different assets, you find different manufacturers, and you have to develop proper drivers for interacting with the systems. We were asked to develop the possibility to send multiple commands to this remote system in order to have a massive programming of thermostats. They wanted to control from remote, from the central headquarters, what happened in the remote offices. Then we were asked to acquire energy consumption and production data. And last but not least, to integrate everything, now that the field was well known, with the company management system that in this case is IBM Maximo. The second step was to view and compare energy consumption data based on historical trends and to configure advanced analysis on energy consumption in order to add some value added to the visibility of the field. As already said, and we can move to the one that show a bit more the complexity of the project. We had to integrate hardware from 5 different vendors with all the difficulties that you can imagine. We have to integrate more than 1,300 devices throughout the whole nation. The project spanned over 10 years. Now we collected millions of measures, and we had to bring everything in a single system and to integrate it with the IBM Maximo system management that was already in place in the bank group. So a complex project, an extensive project. As you can see, we cover most of the regions in Italy and all of the remote headquarters of this primary bank group. The target solution we developed then included several different components. Our Energy Revolution Adverto system for the data collection, Energy Revolution ESO system for the energy efficiency, Energy Revolution Teneo system for the asset management, to integrate the different functionality of data storage, analysis, remote control, planning, energy analysis, and maintenance and management, to provide this through web services and proprietary interfaces so that they could interact with the already existing IBM Maximo system. And of course, and this is the things that I think you are most interested in, we had to develop some dedicated drivers for all the hardware or the heterogeneous hardware we found at the field level in order to be able to get the data out of the remote offices and to send the set point and the control to this asset in order to control the energy consumption. The results we achieved and the benefits we brought to our customer. As I said, the commissioning of the platform happened in June 2014 and allowed the bank group to have a full visibility of their headquarters. The contract has been just renewed for a couple of years more, so we are going to continue. We will have more results. The main benefits that they were able to achieve was the energy savings, basically. An average annual saving of over 15% of energy consumption, and last but not least, a return of the initial investment within the first years of operation. So this is the demonstration that full visibility, full controllability of the assets bring benefits at last. So as takeaways, as I promised at the beginning, in order to, let me say, close the cycle from the Smart2B, the research approach and ontological approach, interoperability with Data Cellar, and down this case history, I took a few slides from your Smart2B brochures so that I could highlight something there. When you said at the beginning that the building as of today have low level of smartness, no ICT integrated, low digitalization, and so on and so forth. Yes, that's true. The truth is out there. You're right. Nothing new, but when you have to do something for a customer, you really find out that even for a primary bank group, when you go to the remote headquarters, you find that you have a very limited controllability. You find heterogeneous hardware to integrate, and that could be a headache for the system integrator and solution provider. On the right side, when you propose your innovation with Smart2B and making buildings smarter, just take into consideration this is something good for us as a system integrator and solution provider. Make the system integrator life easier. So consider when you release your results and when you pre-industrialize your results that there might be steep learning curves for people that is acquainted to do delivery for customers and not fresh, let me say, in the research domain. They might have a limited budget, they have a constrained schedule, so the value added of innovation should bring not that much further burden to the solution provider and system integrator. Then, do not underestimate the heterogeneity in real-world application. As I said, it was just 5 manufacturers, but it was really challenging and demanding to integrate everything we found at the field level in the remote services. Consider also that usually you have limited possibility for updates and maintenance. You go there, you find out that you have systems that are quite obsolete. There is no one that knows how to update them. There is no firmware update. You have to integrate everything, and you have to find a solution in order to bring the full controllability and the visibility to the central system. From passive to active building, yes, this is a still long way to go for most of the tertiary building. But for example, this is something interesting for us as Algovat, as a solution provider and the system integrator in the energy domain, but also for Smart2B. I see that you mentioned there SEX, that is the energy community, the citizen energy community, CEC, and the renewable energy community as well. This is something that building from passive to active will definitely boost the take-up of the solution there. So thank you very much. I hope I stayed in the 10 minutes. I failed to start the chronometer, but I think that I was complying with the schedule. Thank you, Simona.
Okay. Thank you, Stefano. Thank you very much for your presentation. And as we are now done with the session, we can now move to the Q&A session. We already collected some questions for the speaker. So without further ado, I will give you the first question. First one is for Jesus and Anastasis. In your opinion, what would be required to integrate a platform like Smart2B in a data space as it is envisioned in Data Cellar? What are the main advantages of doing that?
Thank you. Okay, so since it says both Jesus and Anastasis, I guess I can go first. Thank you, João, for the question. Well, actually, the focus of Smart2B for me is more aligned with increasing the smartness level of the actual building stock that we have. Obviously, that is quite aligned with the improvement of energy efficiency and management. I will say that the focus is on the, let's say, it will be useful because increasing the smartness level is quite aligned with the energy efficiency. We are also focusing on improving the occupant comfort and well-being. So I guess that those two things are very well aligned and very well mixed together. And with regards to what will it take, we have experienced during Smart2B that there are different stages that the pilots are going through. The project includes demonstration pilots. The pilots have original, let's say, a smartness index. So they go from, let's say, a lower score of smartness, and they transition through the innovations that we have been installing and demonstrating in the project to a higher score, so a higher smartness level. So I will say that for the Smart2B concept to fit into the energy management, I will say that some kind of integration of the smartness index to be taken into consideration, to kind of include what they already have. The concept of how a building or a residential dwelling can go from a lower score to a higher smartness score. So that will be my opinion. I don't know if Anastasis agrees with me.
Yes, I fully agree with you, Jesus. And I would like to add concerning the first question, for example, about the integration steps. At the moment, the system architecture in Data Cellar has not been finalized yet. There is in ongoing process to define it. From one hand, we have the concept of connector that is being deployed in the applications of the users. So this could be the case as well. But I have seen also in the presentation that there are some platform APIs that Smart2B has as well, that this could be also investigated. I think there are many benefits to participate in data space. For example, for the scientific community, could be ideal marketplace for data sets that are very valuable for studies, and also for the energy communities for the resource management, the renewables, and the assessment for economic or environmental factors. And of course, building energy performance. That is something that for consumer and prosumers, we also have use cases in data space. Thank you.
Thank you very much for your answers. Our next question is for both Jesus and Stefano. So based on your experience in the field and your knowledge about Smart2B, which are the main features that the Smart2B platform can offer to the current market needs?
Thank you, Alexandra. I guess I can also try to go first. It's about companies and vendors' ego for me. They believe that they're immortal. They are going to be there forever. The major issue that we are experiencing is that the smart whatever, the smart asterisk realm, there is a lot of innovation going on. There is a lot of, let's say, things going into the market every day. And that also has the side effect that many of the companies go obsolete pretty quickly. So it's a matter of understanding how is your solution going to persist over time. So the main difference for me is that companies are, let's say, really ecocentric, and they believe that they are going to be always on business. And that is one of the key factors of this concept, is in the sense that whatever happens, you will be able to implement the concept of Smart2B, regardless of which companies are available or which components are, let's say, able to be purchased. So to me, it will be about future-proofing the solution, to make something that we can actually enhance and increase and improve and extend without being constrained by companies licensing or vendor products going out of business, or sorry, out of stock or something like that. That will be the most important part. And now I will let Stefano give his opinion.
Yeah, thank you, Jesus. As I said, one of the points in the case study, case history I proposed was the efforts done as for the integration and the interoperability with vendors' devices. So anything you can do on the interoperability side, and this is also good for the Data Cellar project, I think, is good for the technical system integrators, because it makes our life easier. It is supposed to be so also. Any let's see, fireware, for example, any effort, any attempts to try and bring the vendors on around a common table and try to agree on a shared ontological view, a shared interoperability API, anything that wraps the complexity into something easier for the technician, allow us to concentrate on the value added and not spend a lot of time in the development of drivers, or just trying to be able to get the data out of the field. So let's try to move a bit further. When you say smart asterisk, smart everything, well, the smart part is on top of everything else. So you should be able, in principle, to give the integration for granted at one point. So anything that goes in that direction, I think that Smart2B is going that direction. As far as I know, from the document I've seen on website, is appreciated, necessary. Of course, then it's a matter of vendor lock-in and having the people sitting together and agreeing in adopting at least partially or at least as a side possibility these interoperability approaches. But this is the only way to go.
Thank you to both of you for your answers. And next questions would be for Anastasis. When the ontology from Data Cellar will become publicly available? And what are, in your opinion, the synergies with Smart2B on this matter?
Thank you. I see it's from Iakovos. Thank you, Iakovos, for the question. The plan is by end of next month to finalize the relevant deliverable. It's 3.1, and it's a public deliverable. So in my understanding, this will be publicly available after the evaluation. So I think within June will be available. And we are very open to discuss synergies with Smart2B on these topics. The specific domain for the buildings, of course, it's part of the ontology, and we can see how also it is expanded in the other domains.
Okay, thank you very much. Next one, again to Stefano. Is it intended to make the collected HVAC consumption data publicly available at some point? Of course, after appropriately anonymizing them.
That would be a good point. I understand Iakovos' interest in that. Iakovos. No, as far as I know, no or not yet. This is something you should, let me say, state at the beginning. So it should have been done, let me say, more than 10 years ago when establishing the contract. I'm not, well, as a research innovation manager, I would be the first to be, let me say, interested in getting some value added out of this large amount of data from HVAC systems, and also all the dynamics that imply them, because I mean, it's not just getting the data of how they behave, but it is about the way they have been controlled in order to save energy saving. This is somehow, well, a lesson learned also for the research innovation, when you have to bridge the gap between research and business, which is not that straightforward even internally, and not that easy. With your customers in particular, I think we tried also to involve them once in a project in order to make some value added out of this business delivery. They were not that much interested, because for such a large bank group, the research is not that, let me say, convincing. But well, I'm not closing the possibility to get something out of that. For the time being, it's not yet public available. Sorry.
Okay, moving forward, Jesus. With the existence of so many devices, legacy equipment, smart appliances, sensor, etc., how can we in the future ensure that all or most of the appliances can be integrated into a platform similar to Smart2B without much difficulty, for example, without the need of technical installers, but by, for example, common user?
Okay, thank you, Miguel, for the question. Well, the main focus is to employ some kind of gateway or adapter or hardware component that is going to be plugged to the legacy component. For now, we have seen many market solutions that are focusing on adapting whatever is being installed on the building to connect the information with the internet. However, the main goal or the main problem is that companies are, let's say, they are greedy, so they are trying to impose their own platform. So it's about making sure that the product that you're buying, the adaptation or the gateway or the translator or whatever you might call it, is compatible with open standardized protocols and data formats. And this, well, it's actually a contrasting problem, because most, let's say, the companies that are better positioned are trying to vendor lock the user, so they implement everything in a very simple manner, So it's easier for the end user to buy something which is very well supported by the vendor and use that platform. You don't need specialized knowledge. However, you lose the integrability of your solution. So if that company in the future goes under, or they start to impose I don't know, some kind of maintenance fee or some kind of payment, then you're basically in a bad position. It's actually a really interesting question. Thank you for that. It's an ongoing effort. So I will say for now, try to focus on products that are focused on open standardization protocols and stay away from solutions that are basically tying or they can couple with some kind of vendor-specific platform, because even if they are easier to use for not technical users, at the end of the road, they impose some kind of limitation or some kind of issue. So I will suggest doing that. Yeah, thank you.
Okay, we have a couple of other questions coming in the chat. So this one is for Jesus and Anastasis. In my opinion, some of the explanation of entities in pre-existing ontologies are very concise and can be easily misunderstood. For example, when modeling a gateway in the Saref ontology, can we model it as a device or as a system using the Saref for system ontology?
Okay, Anastasis, do you want to go first?
Yes, thank you, Jesus. This is very interesting question and very much to the point. Let's say we have faced this challenge already in Data Cellar, and the answer is that first we have started by identifying the taxonomy based on Saref and the other existing ontologies, and then we have extracted the requirements from the validation cases, and we have the taxonomy that takes into consideration the available data from buildings, from the areas, from the energy communities, etc. And now we are at the stage that we are doing a mapping in order to see how to, let's say, extend, if needed, the available structure, or how to better map everything together. So yes, this is an important step, and we need to define it as well, also with the common ontology vocabulary. So to see each term where is reference to. Thank you.
Yeah.
Okay. Last question will be for Jesus. So looking at the ongoing AU project, the majority of them are developing their own platform. In this context, what differentiates Smart2B from the other platform? And in your perspective, which are the main strengths of the platform?
Okay, thank you, Felipe, for the question. So I will say that the current efforts of Smart2B, sorry, for European projects, when put in contrast with Smart2B, are their demonstration or their concept is tightly coupled with their pilots. So what I have experienced before is that they are tightly connected, and it's quite difficult to, let's say, separate the concept from the pilot. The major goal on Smart2B is something that we take a lot of care of. We constantly keep track that, okay, is this solution going to be useful beyond the demonstration pilots that we have? Is this going to be is this going to enable other developers and other ICT vendors to enhance and increase the solution? Is this going to be applicable in a different scenario? So that is one of the main regards that I think is a focus, a strong core focus for the project. I have previous experience with other European projects, and typically what happens is that they define the solution, or they define their contribution based on the pilots that they have. We are trying to steer away from that. We are first focusing on the solution and the concept, thinking in the future. And then we are trying to refine and demonstrate that based on the pilots. One of the major strengths of Smart2B platform will be its interoperability. We are focusing on innovations, state-of-the-art solutions for making the platform modular, for making the platform easily integrable with other vendor solutions and other freely available components and software libraries and so on. So one of the main goals is to make everything kind of like a puzzle where you can only grab the pieces that you need in case that you have, let's say that you have a very strong AI solution for controlling the buildings and you want to only implement what is missing from your solution. I think that Smart2B is actually a good fit for that. You can capitalize on the components that you actually need, and we are not forcing you to use the whole box, let's say. So this is also one of the key objectives of the platform, to make possible for service providers to connect with their ICT components and their devices in buildings.
Okay, thank you very much. And this last question is for all of our speakers. So, in your opinion, should the energy sector have a common ontology? And if yes, what is missing for having it in the near future?
If I may start on this.
Go ahead.
In my understanding, the challenge is to have a degree of harmonization. So it's not so easy to have a common ontology Europe-wide, and also most of the projects have some specificities that maybe it's a little bit monolithic approach to say that we have a similar ontology for everyone, but we need to see the interoperability aspects to have, let's say, a harmonization as much as possible, and then also have some freedom to let's say have specific also solutions. This is my personal opinion.
I don't know, Hazel, okay, may I? I don't,
Yeah, of course, go ahead.
Jesus finish. Well, when I was playing with ontologies and web semantics several years ago, I was fascinated by the fact that being a biomedical engineer and having to cope with the IT guys, I could spend my, let me say, love in philosophy and biological way of thinking instead of coding in order to support them. The question made by one of our guests about what should I use if this instance instead of the other instance the of ontology. Well, it's something that is really related to a philosophical approach. On the ontological representation is a way you formalize the things that exist. I mean, if you go back to the strict definition. So I found out during the years that too many ontologies maybe were developed by technicians for the sake of interoperability, which is good because I mean, an ontological view or a taxonomical view is something that you agree upon in order to exchange data, and that's fine. The development of an ontology is something that really should depict the reality of what exists in an agnostic way, and you should adhere then. That could mean that the technicians should make let me say, a bit more effort in order to understand a level of sophistication that is higher than expected, but the ontological view should be something agnostic. So an ontology of the energy domain, first of all, would be fascinating. I think that would be very complex because the energy domain is very complex and very large. So probably you should have different aspects of the energy. But I mean, as I said in my presentation, the truth is out there. The ontology is a formalization of a conceptualization. Something, I think the definition, the initial definition of ontology was something like that. So it's something that you should spend a lot of time into the development, and should be something that, I mean, with minimal modification afterwards. You would spend a lot to do it completely, but that would be agnostic and a reference one. All the other ones are good and complex and nice attempts to find a good level of agreement in terms of interoperability.
Okay. So yeah, thank you, Anastasis and Stefano. So for me, it will be to take care of the representation of the different occupants and the different roles, not only the technical aspect, because also legislation takes a big part. When we define what a energy community is, we have found that actually in different countries in the European Union, they have different definitions, they have different limitations. Let's say that national and local laws make things quite messier. So I will say that I will suggest to take into consideration people without specialized knowledge, take into consideration something that is able to fit the local or the national regulations for all of the countries. If done so, which I think it's quite a challenge, I will guess that will be quite useful for the sector. It will be important to have that into the different developments that are taking place in the research projects in the EU space.
Okay, thank you all. So I think that we don't have any more questions. So thank you again to our speakers for answering the question and of course for their presentation. It was a pleasure to have you with us. And the video of this session will be available in the next few days on our Smart2B YouTube channel. So thank you for joining our third innovation webinar and have a great day.
Thank you very much. Bye-bye.
Thank you. Thank you.
Thank
very
you.
much.
Bye.